10th Standard ICSE Chemistry, Chapter 3A, Part 2, Salts. A salt is a compound formed by partial or complete replacement of the replaceable, that is ionizable, hydrogen ion of an acid by a basic radical. That's a cation. It can be a metallic ion or ammonium ion. For example, you have sulfuric acid. It's dibasic. It has two replaceable hydrogen ions. If I react it with an alkali, that is a base, then a neutralization reaction will take place, resulting in the formation of salt plus water only. Notice that in the first equation, since NaOH is insufficient, an incomplete neutralization will take place. That is, out of the two hydrogen ions, only one will be replaced with sodium ion, that is a cation, and the other hydrogen remains as it is. So such a salt is called an acid salt, because when dissolved in water, it will give hydronium ions and it will turn blue litmus red. But we can't call it an acid because an acid by definition, when dissolved in water, gives hydronium ions as the only positively charged ion. Whereas here I have two positive charged ions, sodium as well as hydrogen. So it's a hybrid between acid and salt, so it's called acid salt. But what if we have excess or sufficient NaOH? In that case, both the hydrogen ions will be replaced by metallic ions, that is sodium ions here, which is called a basic radical. And hence, we get a normal salt. And this is complete neutralization. So, acid salt is formed by partial replacement, normal salt by complete replacement. Examples are given. This is produced by using insufficient base, and here we use sufficient base. Acid salt exhibits all the properties of an acid in solution form, whereas normal salts don't. Notice that monobasic acids like nitric acid, hydrochloric acid, and acetic acid, they cannot form acid salts because acid salts are formed by partial replacement of hydrogen ion. They have only one replaceable hydrogen ion. They are monobasic. So partial replacement is not possible. Only a complete replacement is possible to form a normal salt. But if the acid is dibasic or tribasic like these, then we can have partial replacement to form acid salts and complete replacement to form normal salts. Now we have a GR, please note it down. Why is HCl? Why does HCl form only normal salts? Because it has only one replaceable hydrogen ion which can't be partially replaced by a basic radical. Similarly, we have a concept of basic salt. So if I start with CuOH twice, copper hydroxide, and out of the two hydroxyl ions, one is replaced by an anion, that is an acid radical, and one OH still remains. That is called a basic salt. For example, basic copper nitrate and basic copper chloride. So CuCl2 was copper chloride, but one chloride was replaced with OH. Double salt, mixed salt, and complex salts are cancelled. Then we have the solubility table, which is very important. You should remember this. Notice that all sodium, potassium, ammonium salts, without any exception in these cases, will be soluble in water. So even though I'm saying that all carbonates are insoluble, but when it comes to ammonium carbonate, potassium or sodium carbonates, they are soluble. However, potassium bicarbonate and sodium bicarbonate are sparingly soluble. Also, all hydroxides are insoluble, but calcium hydroxide is sparingly soluble. It's a weak base or weak alkali. All chlorides are soluble, but again exceptions, lead chloride, silver chloride, mercury chloride are insoluble. By the way, lead chloride is soluble in hot water. So we need to remember all the exceptions as well. Next, preparation of salts. Well, there are 6 ways to prepare them. The type of question asked in the board exam is, they will give you the name of the salt, let's say ferric chloride, and they will ask you what is the method used to prepare it. So you should answer direct combination, also called synthesis. And they may ask you to write the equation as well. Now, multiple answers may be possible for some salts. Let's talk about the first method, direct combination. Synthesis, as the name suggests, is always between two elements to form a compound. It is used for making binary salts, that is, salts having only two elements, as you can see here. And they may be soluble or insoluble. Solubility should be remembered by us. And whenever you write an equation, make sure you balance it. Second method is displacement method. We have two reactants and two products. This is useful for making soluble salts of active metals. So we take an active metal that is above hydrogen in the activity series and you react it with dilute acid to form salt and hydrogen gas. So notice how iron has displaced hydrogen from the acid to form ferrous sulfate and hydrogen gas is given out. We can't use this method to form lead salt because lead salts are not soluble. So coating will be formed on the metal and the reaction will stop. Next, precipitation reaction. It's a type of double decomposition reaction where we have two reactants and two products, and one of the products is insoluble, so it's a precipitate. So these are the salts formed by this method. Notice that both the reactants are soluble and one of the products is insoluble. But what if we start with an insoluble reactant and we want another insoluble salt? Then this method won't work. For example, if we start with lead carbonate and if I want to convert it to lead sulfate, we can't just say lead carbonate plus sodium sulfate will give you lead sulfate. No, double decomposition reaction or precipitation reaction won't happen, because since this lead sulfate is a precipitate, it will form a coating on the lead carbonate and further reaction will stop. So what we'll do is a two-step process. We will convert the lead carbonate into a soluble salt, that is lead nitrate. And then the second step, it's easy to convert lead nitrate into lead sulfate. So these are the examples of the two-step processes. And this is what I just talked about. Lead carbonate converted to lead nitrate by reacting with nitric acid. Now lead nitrate is soluble. So soluble plus soluble salts, double decomposition, precipitation, lead chloride will be formed, or lead sulfate can be formed. So mark this as a GR, the brackets, and remember these examples. And this is true not only for lead salts, even for other salts like zinc salt, which is insoluble, and they want a product also as insoluble. Next method is neutralization of an insoluble base. So these are the insoluble bases. You react it with acid to give salt and water only, and the salts are obviously soluble. But what if we start with a soluble base, that is an alkali? In that case, again, we use neutralization reaction, but titration. This should be mentioned in bracket in the answer. This is useful for salts of sodium, potassium, and ammonium because they are soluble. This is how titration takes place. This is a burette, and there is another instrument called pipette being used. You will do this in practicals. It's not there in the theory exam. We only have these equations. And the last method is action of dilute acids on carbonates and bicarbonates. Now we know that whenever an acid reacts with carbonates and bicarbonates, we get salt, water, and carbon dioxide gas. So again, the salts formed are these, which you have to remember. Now, notice that these salts can be prepared by other methods as well. For example, copper sulfate can be prepared by neutralization as well. So you need to remember all the methods. Now some cancellations, page 52, 53, 54, 55 are all cancelled. They are practicals, not coming for theory. Even all of this is cancelled. Just extra information, hydrolysis means it's a reverse of neutralization reaction, where salt plus water gives base and acid, but it's not there in syllabus. Now here, action of acids on salts. We know that when an acid reacts with carbonates and bicarbonates, it forms salt, water, and carbon dioxide. What about sulfites? Well, it gives sulfur dioxide gas. With sulfide, it will give us hydrogen sulfide gas, no water here. Observations can be asked. For carbon dioxide, well, we've studied this in practical chemistry. A colorless gas is released which turns lime water milky but has no effect on acidified potassium permanganate solution. Sulfur dioxide also turns lime water milky, but it turns acidified potassium dichromate from orange to clear green. Or you can say acidified potassium permanganate from pink to clear colorless. For hydrogen sulfide, the test is it turns moist lead acetate paper silvery black. Next, about the salt. The definition of salt I've already explained, and I've explained that salts can be of three types in fact: normal salt, acid salt, and basic salt. Now, the solubility of metallic salts is very important to be studied. We should know that all sodium, potassium, and ammonium salts, are always soluble in water. Exception, sodium and potassium bicarbonates. They are sparingly soluble. Next, all nitrates and nitrites of any metal or even ammonium is always soluble. So remember, nitrates and nitrites are always soluble. Bicarbonates are always soluble of any metal, but the exceptions are already mentioned of sodium and potassium. Sulfates, almost all sulfates are soluble with 4 exceptions: lead sulfate, silver sulfate, calcium sulfate, and barium sulfate. Chlorides, all chlorides of all metals are soluble, but here there are 3 exceptions which we should remember: lead chloride, silver chloride, and mercury chloride.
Now, the remaining salts, which are sulfides, carbonates, oxides, hydroxides, and phosphates, these salts are all insoluble. Of course, the ones for sodium, potassium, and ammonium will be soluble, but for other metals, it is insoluble. A point to be noted, calcium hydroxide is sparingly soluble. And finally, let's study the general methods of the preparation of salts. There are totally 6 methods. Method 1 is direct combination, also called synthesis. It is used to produce binary salts, which is salts having only 2 elements, one metal and one non-metal. The salts produced here may be soluble or insoluble. Now, formation of salts is a very important question which is always asked in exams. They will give you a salt and ask which method should be used to prepare it. Some salts may have multiple answers. The next method is displacement reaction. It is used to make soluble salts of active metals. So we need to remember some of the hints because there are so many equations to remember. So an example would be take an active metal and react it with dilute acid to give a soluble salt, and of course hydrogen gas will be released. The third method is precipitation reaction, which is a type of double decomposition reaction. Some double decomposition reactions are precipitation, whereas some are neutralization. In precipitation, we see that a soluble salt, reacts with another soluble salt solution. So these are 2 solutions which are mixed together to give 2 new salts, out of which one will be soluble, but the other will be insoluble. It will precipitate out and we can filter it out, and that's how we get the salt we desire. However, if I wish to create an insoluble salt from another insoluble salt, then it will be a 2-step process. For example, if you are given lead carbonate, now lead carbonate is insoluble and we have to prepare lead chloride from it. Then how do we prepare lead chloride from lead carbonate? So first step, convert the insoluble salt into a soluble one, and that is where the knowledge of solubility of salts comes useful. So lead carbonate, when reacted with nitric acid, which is dilute, gives you lead nitrate, which is a soluble salt, plus some other products. Now we can use this soluble salt in the precipitation method, which is the above equation, to get lead chloride, which is again insoluble. So it will be a 2-step equation. Next, neutralization. Neutralization is always between an acid and a base. Here, this method is useful for producing insoluble bases. For example, copper hydroxide was an insoluble base. It was added to dilute sulfuric acid or vice versa, and you get a soluble salt. However, if we are using a soluble base like sodium hydroxide, ammonium hydroxide, and potassium hydroxide, then the method is called neutralization titration, in which we need to be sure about the amount of acid and base that we are using. But even this is neutralization where salt and water is produced only, and the salt is obviously soluble. And finally, the action of acid on carbonates and bicarbonates, which is decomposition by acid. You take any carbonate or bicarbonate, react it with a dilute acid, you will get a salt, and of course water and carbon dioxide.
Hi students, this is AJ sir. If you like this video, press the like button. If you would like to enroll for my online test series or online lectures, email me or message me on Instagram. Check the description for more information.